Hello, my name is Lance, and I'm going to be talking about the Dirac atomic model. In order to fully understand what the Dirac model is and how it answers important questions, it's useful to look back upon previous atomic models proposed throughout history and understand their strengths and shortcomings. In 1904, scientist J.J. Thomson created the familiar rudimentary plum pudding model of the atom. Here, the electrons are situated in a mass of positive charge resembling plums in pudding, hence the moniker. This model was able to accurately predict that the atom was comprised of distinct negative and positive charges, but failed to predict the structure of the atomic nucleus. Just 7 years later, in 1911, Ernest Rutherford created what was known as the planetary model of the atom. In this model, negatively charged electrons orbited around a single positive charge. Though accurately able to predict the orbiting nature of electrons, this model failed to recognize the existence of neutrons. Additionally, the model predicted that the electrons would gradually lose energy and spiral into the nucleus. In 1913, Niels Bohr produced another model of the atom. This time, the electrons were locked into quantized energies as they orbited the nucleus, meaning that they would not spiral inward. Additionally, this model accurately predicts the wavelengths of the photons emitted as electrons jump from higher states to lower ones. Before the Dirac model was introduced, atomic models such as the ones mentioned did not incorporate the intrinsic angular momentum of electrons due to the rotation about their axes. Neither did they incorporate relativistic effects, which is important as orbiting electrons can reach significant fractions of the speed of light. Due to its nature, there doesn't happen to be a diagram for this particular atomic model. Dirac's thoughts on this matter were crystallized with this particular quote to Schrödinger. The main object of physical science is not the provision of pictures, but is the formulation of laws governing phenomena and the applications of these laws to the discovery of new phenomena. If a picture exists, so much the better, but whether a picture exists or not is matter of only secondary importance. Instead, we'll use the Dirac equations themselves to build a more firm understanding of his model. Here is the Dirac equation for a free electron in its most simple form. I represents, as usual, the square root of -1. Gamma represents 4 4x4 arrays of numbers. Delta represents rate of change calculations with respect to 3 spatial dimensions as well as 1 of time. Psi is a 4-component wave function for the electron, and m is the rest mass of the electron. Here's an extended version of the Dirac equation for a free electron. Here, constants alpha sub 0 through 3 are 4x4 arrays of numbers, m is the rest mass, and c is the speed of light. These two equations are both Lorentz covariant, which is to say they hold true in all inertial frames, accounting for relativistic effects. Using these equations, one can precisely describe the hydrogen atom's known fine structure frequency spectrum of light, as well as acquire the 4 quantum numbers describing each electron in an atom. By way of Dirac's expressions, he was able to predict the subatomic behaviors of electron spin and spin-orbit coupling. Spin-orbit coupling involves interacting magnetic fields inside the atom which alter the electron's energy level. The electron's rotation about its own axis, as well as the electron's orbiting behavior about the nucleus, each produce their own magnetic fields shown here, which, in turn, interact with each other, altering the electron's energy. Because Dirac's expressions use a 4-component wave function instead of a 2-component one, the electron's possible stationary states were doubled to what were previously expected, creating a state of what Dirac called negative energy for every state of positive energy in electrons. This means that Dirac's model allows for the kinetic energy of the electron to be negative. To make sense of this, Dirac interpreted the negative energy to be associated with a positron, the antiparticle version of the electron, with mass equal to that of an electron and a charge which is directly opposite. Another interesting conclusion that Dirac drew is that the electron orbits the nucleus at the speed of light. This is in direct contrast to previous observations which clocked the electron at subluminal speeds, but Dirac stated that it was the charge of the electron and not the mass itself which orbited at the speed of light. In other words, Dirac proposed that the electron's charge is in fact not situated at its center of mass, and moves at a higher speed.